हमने उसी का एरिया हमने समेशन करके समेशन किया, क्योंकि हम इंटीग्रेशन करते हैं। हम जब भी ऐसा एरिया को कैलकुलेट करते हैं, इंटीग्रेशन बेसिकली क्या होता है, इंटीग्रेशन में बेसिकली हम एरिया ही फाइंड आउट करते हैं कि एक छोटा सा एरिया लिया, उसी को ऐड करते हुए चले गए और उससे एडिशन से जो भी कुछ मिला वो एक एरिया ही होता है। इंटीग्रेशन इज जस्ट फाइंडिंग आउट एरिया। ओके, सो यहाँ पर भी इंटीग्रेशन का यूज करके ही हम एरिया फाइंड आउट कर रहे हैं। ओके, सो in general, however, a plane area doesn't may not have any axis of symmetry. In that case, the principal axis may be located provided its properties about any pair of rectangular axis x and y are known. कि अगर किसी भी प्लेन एरिया में अगर हमें एक्सिस ऑफ सिमेट्री नहीं मिलती है तो उस केस में क्या करेंगे, जो प्रिंसिपल एक्सिस है वो कहीं ऐसी जगह पे लोकेट करेंगे जिससे कि हमारी एक्सेस और वाई वाई की लोकेशन जो है वो हमें मिल सके, उसकी प्रॉपर्टीज के बारे में हम जान सकें। So what we do, let's assume that small x and y be the coordinates of elementary area delta A with respect to x and y axis. Now we are taking x and y axis, not u and v. Okay, and u and v be the corresponding coordinates with respect to principal axis uv. So let's see what he is saying. Suppose this area is there, this total area is there, and the corresponding and the coordinates of this area will be x and y because it is lie in this same plane, and the corresponding coordinates according to your uu and vv axis will be like this will be u coordinate and this will be your y coordinate. Okay, this will be your v coordinate, this will be your v coordinate, this will be your u coordinate, and u coordinate is equal to x cos alpha and v coordinate will be equal to y cos alpha. Okay, y cos alpha. So by definition Ixx will be equal to, means moment of inertia about x-axis is summation of y square into delta a, and moment of inertia about y-axis is summation of x square into delta a, and moment of inertia about x and y-axis is summation of xy into delta a. Similarly, if we talk about the moment of inertia about your uu axis, it will be summation of v square into delta a and so on. Okay, so the relationship between u, x and y and v coordinates are u is equal to x cos alpha plus y sin alpha and v is equal to y cos alpha minus x sin alpha. So it is already clear in this figure. Okay, that if we are talking about v is cos alpha because cos alpha is taking place from here to here, cos alpha minus x sin alpha. And what will be the value of your u? U will be the cos x alpha plus y sin alpha. So your IUU will be summation of v square into delta a. We'll put the value of u and v we'll get these values cos square alpha, y square alpha, sin square alpha into summation of x square alpha into a, and we have expanded this equation. On expanding, what we got is ixx cos square alpha plus iyy sin square alpha minus ixy sin 2 alpha. So what you got? We got iuu in terms of moment of inertia about x and y axis. Okay, we got the moment of inertia of iuu in terms of x and y axis. हमें क्या मिला कि मोमेंट ऑफ इनर्शिया जो uu एक्सिस का है वो किसके रेस्पेक्ट में मिला है, आई एक्स एक्स सॉरी एक्स एंड वाई एक्सिस के रेस्पेक्ट में. एनी प्रॉब्लम इन दिस?
No, sir.
Okay. Then similarly we can find out the moment of inertia about your VV axis, which again will be in terms of your x and y axis. So it will be ixx ixx sin square alpha plus y cos square alpha plus ix sin 2 alpha, and I uv moment of inertia about u and v axis is ixx minus iyy divided by 2 into sin 2 alpha plus ixy cos 2 alpha. Okay. Wait a minute. ज़्यादा बड़ा कर. Okay. And we know that u and vb are your principal axis. What is there? U and vb are your principal axis as we have assumed. So summation of I uv should be 0 if they are principal axis. So we will equate this 0 to the value which we got. So from this value, what we have find out is tan 2 alpha is equal to minus 2 I xx sorry I xy divided by I xx minus I yy. Okay. Now we know Ixx, Iyy and Ixy and the angle alpha can be calculated from this formula. We can calculate your alpha value as well. Now we will substitute the alpha value in your equation. Okay, in this equation and in this equation. By putting these values, we can easily find out the value of your IUU and IVV. Now we can rewrite these equations, and these equation can be formed into this kind of alternative forms. Like IUU will be IXX plus IYY divided by 2 plus IXX minus IYY divided by 2 into cos alpha minus IXY sin 2 alpha. Similarly, your IY will be there. Now from these equations, we can find out your value of sin 2 alpha and value of cos 2 alpha. Now, upon putting the values of your sin 2 alpha and cos 2 alpha, further these equation can be reduced these two equations can be reduced into this form. IUU is equal to Ixx plus Iyy divided by 2 plus under root Ixx minus Iyy divided by 2 whole square plus Ixx xy whole square, and IVB is the complementary part of this. And as you can see, these formulas are similar to the formulas which we have derived earlier in your structure analysis 1 in principal plane theory or principal strain theory. Okay. Now, by using this equation, you don't need any alpha angle also. You just need to have the moment of inertia about x-axis, y-axis, and ixy axis. So this is the analytical solution. Now, if you want to find out these values by using graphical solution, you can also do that by using the graphical method. What is that graphical method? That is Mohr circle. Okay, and this equation is similar to the equation Mohr circle equation which we have derived earlier in your previous semester and structure analysis first. Okay, so graphical solution, we are having two methods. One is Mohr circle method, another method is circle of inertia. Okay, first we will discuss about your Mohr circle method. So upon pondering upon about this equation, we see that these equations are very much similar to the equation which we have derived earlier in Mohr circle equations. Okay, so from here we can easily find out your Mohr circle equation. So what we got as sigma 2s sigma x plus sigma y divided by 2 minus sigma x minus sigma y by 2 plus tau square. This is the equation which we got earlier, and 10 alpha is 2 tau divided by sigma x minus sigma y. Okay, now IUU and VB equation can be simply be transformed into this. They are already in this transformation equations. So by using this, we can easily make our Mohr circle. So what is this? As you just see, from origin point to the ending point of the circle, or you can say second point which is coinciding this on this axis is actually the value of IUU. Okay, this distance is IUU. The point at which the circle is coinciding twice is IUU, and at the first point it is IVB. As you can see, this point is IVB and this point is IUU. So the diameter of circle can be found out by using IUU minus IVB. This will be the diameter, IUU minus IVB. Now this perpendicular how we got this perpendicular? Just simply rotating our circle, sorry, just rotating about the axis, about the center of the circle, and put a angle which we got like 2 alpha. Draw this, and wherever it coincides with the circle, just put a perpendicular over there. That perpendicular will be equal to, or the distance of that perpendicular equal to, like in first case it is I by y, and second case it is I axis. And the construction of this circle is very much similar to the construction of more circle in your principal axis theory. Okay, I hope this is clear to you all. Now if it is not, then let me make it. Just wait for the whiteboard. Suppose this is your axis. Okay, and you want to construct the more circle out of it. So as we have seen, I UU and I VV minus equal to diameter of the circle. So your radius will be I UU minus V divided by 2. This will be the radius of your circle. Okay. Are you getting my point?
Yes, sir.
So how you will construct? You need to know the origin point or the center point. You got the radius. So what will be the center point of your circle? Yes, anyone?
Between diameter of the radius.
Between diameter of the radius? No. It will be, center point will be I UU divided by 2 minus your I VV. Okay. So now we got the center point. Just put the center point, and based on this R which we got, we will construct our Like if it is the center point, we will construct our circle. This is your IVV. This is IUU. Okay. This is the center point. Okay. So if you see this, this will be what will be this?
One.
This center point will be this. Okay. First you have to add this one with this, and half of that will give you the center point of the circle, and the radius of the circle is IUU minus IVV divided by 2. Now you know you have drawn your circle, so now you have to find out the your like like in a real case we have to find out your shear stress. Similarly here the IXY plane, IXY plane, or you can say IUV plane. For that, what you need to do, you are having a alpha value. We need to take 2 alpha value, and we will move either clockwise in clockwise direction or in anti-clockwise direction. Okay, based upon the condition, if like if we move in this anti-clockwise direction, so let's suppose if it is 2 alpha, if it is 2 alpha, so wherever this point is coinciding, just you have to put a perpendicular over there. Okay, similarly you need to do here also. This will also be 2 alpha, and you have to put a perpendicular over here also. Okay, so what will be this? What will be this? This will be your either IXY or IXY. Okay, but that depends on, because this will be positive I X Y. This will also be IXY. This might be negative. Okay, and whatever value you got here, that will be corresponding to your IYY and IXX. This is corresponding to I, Y, Y, and this one is corresponding to I, X, X. Okay, so from this circle you can easily find out in this way. let us take an example first, then we will move further. Determine the principal moment of inertia for an unequal angle. Okay, what you have to do, you have to find out the principal moment of inertia for an unequal angle 60 into 40 into 6 mm as shown in figure. So see, this is an unequal angle whose one leg is 40 mm, another leg is in 60 mm. Okay, and the thickness of this angle is 6 mm. These dimensions are given. As you can see, both the legs are unequal. So this is an unequal angle. We have to find out the principal moment of inertia. Okay. So first we have to assume that O is the centroid of the section, and x axis be at the distance cx from face, and y axis be at a distance cy. Like this is the O, centroid of this whole area, and the distance this is cy. Okay, this is cy and this one is cx. There is a misprint. This is your cx. Now area will be equal to area 1 plus area 2. What is your area 1? Area 1 is this 40 into 6, and area 2 is 54 into 6. Why 54? Why not 60? Because that 6 is already counted in this. Okay, because we have already counted that 6 in this 40. Okay, so the total area of this angle section is 564 mm square, or you can say 564 mm square. So now we will find out what is cx and cy. Cx is 40 into 6 into 3 plus 54 into 6 into 33 divided by 564. So we are actually finding out the cx and cy by using the area into lever arm questions. So area is 40 into 6, 40 into 6. So and half of this is 3. Similarly, 54 into 6, and whatever remaining is from this part is,
Three.
yes, not 3. This time it is 33. Yes, anyone can tell me that how 33 came? Yes, anyone? No? Okay. We are talking about Cx. So whatever distance we will take, that should be according to your x-axis. Okay, that should be according to your x-axis. Let's come to the whiteboard. You are having your next class also?
Yes, sir.
Which class?
Concrete technology.
Okay. So I think for today this is enough, because this is a very lengthy question. We will discuss this numerical in your next class. Okay. For today,
Okay,
I
sir.
think this is enough.